Welcome everyone. This is an extension of 7.1 of the Trig Identities. And all we're doing today is we're just gonna go into examples. So in this lesson, we are simplifying, verifying, or proving, okay? Those are the directions, okay? We're gonna simplify, or we're just gonna verify that that's true, or we're gonna prove that's true, okay? So here we have sine of x times secant of x over tangent of x. And what we're going to do here is we're just going to simplify. Okay, we can simplify doing one of two things. We can turn everything in terms of sine and cosine, right? One of our hints from yesterday. Okay, so I'm going to go ahead and do that. I'm going to have the sine of x times 1 over cosine of x over tangent is the sine over cosine, right? Okay. So since this is just the multiplication or division, I'm going to take the reciprocal, use my basic math skills, right? Sine of x over 1 times 1 over cosine of x times, take the reciprocal of this and put it as cosine over sine, right? Basic math, right? Flip the denominator, put it there. And now we have, again, basic math skills, sine on top, sine in my denominator, they cancel out. Cosine in my denominator, cosine in my numerator, they cancel out. I'm just left with 1. Cool? Yeah. So please get to know the reciprocal identities along with the tangent and cotangent and the Pythagorean identity, right? That's what we have so far. This list is going to grow as we go into chapter 7. So this is my next one. We are simplifying. Okay. I see secant squared x, right? Now remember one of the hints or one of the tips that we talked about is if I see a trig function squared, I am going to think Pythagorean identities, right? So here are the Pythagorean identities. Let me put it side by side. Secant squared x minus 1. I know 1 plus tangent squared x equals secant squared x. Can I make this look like that? Subtract 1 from both sides, right? So if I subtract 1 from both sides of this equation, then I would have tangent of x squared x equals secant squared x minus 1, correct? So I'm going to use that fact and substitute this in for this here. So this would be tangent squared x over secant squared x. Okay. And now let's try and turn everything into sine and cosine. Tangent squared would be sine squared x over cosine squared x times or divided by secant squared x is 1 over cosine squared x, right? And then from here, we're dividing two fractions. So we take our denominator and we take the reciprocal, or we take the reciprocal of my denominator. Basic math skills, cancel, cancel. Well, all I'm left with is sine squared x. Okay. All right. Easy. All right. My next one I have is this. Again, to simplify, verify, or prove. For this one, we are simplifying. Our next example is this: cosine cubed x plus sine squared x times cosine x. And we must simplify, okay? So what I can do is I can use my algebra. I can use my algebra to factor out a cosine x, because between this one and this one, they have a cosine, right? That I can take out. So I have cosine squared x plus sine squared x. I see trig function squared, right? I see two of them. What does that equal to? 1. Yeah. So it's cosine times 1, which is just cosine. Okay. So our next example, we have to simplify this out. Now, before I start, in doing this, verifying, proving, or simplifying, you're going to go down a path and think, okay, this is the correct path, right? You're going to walk along. Okay, I'm going fine. And then all of a sudden, it's going to be like, this is getting way too complicated. Okay, let's backtrack. Let's start over. And let's start this up again. Okay, I'm going to go down one of those paths. Okay, just to show you what it will feel like. Okay, and I wanted to kind of introduce another method of simplifying. Okay, so it's twofold. So here, when I want to simplify this, I don't see a trig function squared. I know if I start converting this into sine and cosine, then it's just going to get complicated, right? So what I'm going to do is I'm going to multiply this by 1 minus secant of y, top and bottom. Why I'm doing that is because now my denominator is 1 plus secant y times 1 minus secant y. Does anyone know that form? 1 plus secant, 1 minus secant. What is that? Yeah, it turns out to be a squared minus b squared, right? You guys remember this from previous math classes? Yeah. A plus b times a minus b equals a squared minus b squared. Okay? So if I follow this format and I multiplied it by a plus b times a minus b, this product has to be a squared minus b squared, right? A squared minus b squared is 1 minus secant squared y. Okay? On the top, we have this. I'm just going to write it out. I'm not going to do anything with it just now. Okay? In my denominator, 1 minus secant squared. What is that? 1 minus secant squared. Well, if I look at this one here, I know I have secant squared, right? I'm going to subtract 1 on both sides. Tangent squared theta equals secant squared theta minus 1. But now I need 1 minus secant, right? I have secant squared minus 1. What can I do to both sides here to make it look like that? It's the opposite. Positive 1, negative secant squared, positive secant squared. Divide by a negative, or I'm going to multiply by a negative 1. Okay, by a negative. So this would be negative tangent squared theta equals 1 minus secant squared theta, right? Because a negative makes the positive secant squared a negative secant squared. Negative times a negative is a positive. So I do have this. This breaks out to be negative tangent squared theta. Correct? Okay. Now I'm going to distribute out or FOIL this out and see what I can do from here. So 1 minus secant y, and this should be a y, not a theta. 1 minus secant y minus cosine y times secant y or minus cosine of y, right? I missed this one. Okay, or plus cosine of y. Okay. Do you guys already have that feeling? In the beginning? Where? This one? Minus cosine times secant? Because cosine times negative secant is negative cosine. Yeah. What is cosine y times secant y? This secant y is the reciprocal of cosine, right? Right? So what is cosine times 1 over cosine? Yes, it's 1. Okay? So it's 1 minus secant y minus 1 plus cosine y. Those two ones cancel out. So I have cosine y minus secant y over negative tangent y, tangent squared y. And by now, I'm like, what am I doing? Yeah. I feel like I'm going around in a circle, right? Because from the first till now, the actual problem till now, I didn't really do much. Yeah. You guys feel that way? A little bit. Okay, so once you guys have even like a little inkling of it, go back and start over. Okay. Maybe my first instinct of changing everything into sine and cosine was correct. Right? Secant is 1 over cosine. Now I see a fraction here. So I'm going to put it all under 1. What is the common denominator between cosine and 1? Not a trick question. Cosine. Cosine of y. Right? So 1 is cosine over cosine. So that's cosine of y plus 1. Right? 1 plus cosine of y is in my numerator. So this is this. And this guy turned into this guy. Okay? That's cosine. Yeah. Now I have a fraction. I'm dividing a fraction, so I'm going to multiply by its reciprocal. Right? I know that 1 plus cosine is the same thing as cosine plus 1. So they cancel out, and we just have cosine of y left over. Okay? Look how simple or simple that was compared to this. Right? I'm sure if we stuck with it, we could continue on from here and do that, right? And get cosine of y. But there's definitely a more efficient way, okay? Which I'll highlight in a little bit in one of my examples, all right? So the next thing is to verify or to prove. And these are the guidelines for proving trig identity. Okay, it has all of the tips and tricks that we talked about yesterday. Okay, so the first step is to start with one side. We are going to start with the more complicated side and try to simplify it down to the less complicated side, right? So this is going to be an equation, right? Left-hand side equals right-hand side. And all we got to do is make one side look like the other. Okay, so we're going to start off with one side, the more complicated side, and try to simplify it down to whatever the other side is. Okay? Using trig identities, basic algebra, along with converting everything into sine and cosine. All right? So that's what we're going to do right now with our first example. This one here. First step is to start with one side, the more complicated side. So is my left-hand side more complicated or my right-hand side more complicated? The left one, right? Yeah, with all of these trig functions. Okay, so I'm gonna simplify this side to look like this side. Okay, I wanna get sine squared x. Okay. What we're gonna do here is I am going to distribute out the cosine. Okay, so secant theta times cosine theta minus cosine squared theta. You don't have to write this side out. Okay, we're just working on the left-hand side. Okay, so don't do anything with that. And what is secant times cosine? Okay. Remember our reciprocal identities, secant equals 1 over cosine. So we have 1 over cosine of theta, yes it is, times cosine of theta minus cosine squared theta. So these two guys, they cancel out, and we just have 1 minus cosine squared theta, right? Questions on how I got that? No? Now, if I look at my trig identities, because I do see a trig function squared, I'm going to go down to here. Which one? Well, cosine squared, this is the only cosine squared. Can I make this from this? If I subtract, or I'm sorry, if I subtract cosine squared theta from both sides, right? I would have on my right-hand side 1 minus cosine squared theta, right? Which equals sine squared theta. Yeah. So this equals sine squared theta. And once you get to the right-hand side, right, you're done. Okay? Now I prove that this equals this. I started here. I proved that it equals my right-hand side. So we're done. Does that make sense? Yeah. Okay. My next one that I have is this. What's the more complicated side? Left hand, right hand? The right, right? Now I see two fractions. Whenever you see two fractions, you're going to come up with a common denominator. So the common denominator here would just be the product of the two denominators that I have. One minus sign, one plus sign, right? And so in this fraction here, in order for me to get this denominator, I would have to multiply both top and bottom by 1 plus sign, correct? 1 times 1 plus sign is 1 plus sign minus. Now in parentheses, you must put parentheses around this, okay? Because whatever is here is going to be subtracted. Each and every term is going to be subtracted, okay? So in my second fraction here, I need a 1 minus sign. So I'm going to multiply numerator and denominator by 1 minus sign. That's 1 minus sign of x. Okay. Now in my top, I'm going to distribute out this negative. So 1 plus sign of x minus 1 plus sign of x. What is 1 minus sign times 1 plus sign? What is that? We just talked about the special form, the difference of squares. So that's 1 squared, which is 1, minus sine squared x. Okay? Now in my numerator, simplifying it, 1, negative 1, they cancel out. And sine plus sine is 2 sine of x. Right? Over 1 minus sine squared x. What is 1 minus sine squared x? Sine squared again, so I think of my Pythagorean identities. Which one is it? Minus sine squared, minus 1 minus sine squared equals cosine squared, right? Yeah, I don't have to show you guys the math behind that. So it's cosine squared x. And now I don't know how to simplify. Okay, from here, I don't know where to go. But you know your end product, correct? You know where you have to go, right? You have to do this. You have to get here, correct? So if I analyze what I already have, I have the 2, I have a 2, so I'm good there. I need a tangent and I need a secant, okay? So in the back of my head, I'm thinking I need a tangent and a secant, right? From what I have, the sine over cosine squared. I know secant is 1 over cosine, right? So this big 2, I'm going to leave right there because I'm good with that. So if I take out a 1 over cosine x, I'm left with sine x over cosine x, correct? I can rewrite what I have on top like this, correct? Yeah, basic algebra skills, okay? So 2, I'm gonna make it look like the one I have on top, so I'm gonna deal with this one first. Sine over cosine is tangent. 1 over cosine is secant. So now I have what I need on the top. Okay? That makes sense? So it's literally just rewriting what you already have and kind of thinking that through. Okay? And just pick one thing. Hey, pick one thing at a time. Okay, I already had the 2, so that 2 was simple. I literally chose secant. I need a secant. So I know secant is 1 over cosine. Where do the other ones fall? Well, I have one more cosine that I need to deal with, and I have a sine. That so happened to be tangent. Okay? Cool. My next one, and I have 2 more, okay, is this. Left hand or right hand? The left. I always choose fractions to be more complicated. Okay? So here, I'm going to use that skill and multiply this by 1 plus sine u. Okay? Because 1 minus sine times 1 plus sine, that becomes 1 squared minus sine squared. Right? And I want that sine, or I want that trig function squared. On the top, I'm going to leave it as is. Okay? It's supposed to be a u, not a mu. Okay? So 1 minus sine, if you guys look at your trig Pythagorean identities, 1 minus sine squared, that's cosine squared. Okay? So I have cosine u times 1 plus sine u. And now using basic math skills, cosine cancels out with one of the cosines that I have down here. And I'm left with 1 plus sine u over cosine u. Right? And come to a point where I don't know what to do. Correct? Yeah, because I simplified it down to where I can simplify it. Now again, back of your head, I need a secant and I need a tangent. Okay? They needed to be added together. So I have an addition here. So let me try. I know secant is 1 over cosine. So if I split this up into this and this, right? Which algebraically I can, this is going to be 1 over cosine u plus sine u over cosine u. 1 over cosine is secant, plus sine over cosine is tangent, which is what I need. Okay, so you guys do need basic algebra skills. Okay? All right, we're good. Okay. Before we go on and do this one, I kind of want to share out this. from here, from this classroom to the 1000 building. There are multiple of ways to get there, right? I can go in a straight line. There's a quick way, straight line through, right? Or I can go downstairs, talk to my buddy downstairs, go to the 5000 building, see some artwork in the 4000 building, right? I can go to the 2000 building, see some teachers there, say hi, and then go to the 1000 building, correct? We end up at the same place, right? I just went there more efficiently, correct? Same thing here. There are multiple of ways to prove or to verify, okay? Johnny's way might just be more efficient than your way. That makes sense? You guys are both correct. Yeah, you guys got to the destination. Yeah, but there's a more efficient way, and then there is a less efficient way. Okay? So just don't get discouraged when you're just going down like a long path. Yeah.
Using the less efficient way won't get us talking.
No. Same thing. Okay, so when I look at this, what's more complicated?
Right.
The right? Well, they're both fractions, right? I feel like they're equally complicated. But yes, the right-hand side will be a little bit more complicated. But in terms of this, the most efficient way is to deal with both. To simplify a little bit here and to simplify a little bit here to get to the to verify it. So here first, 1 plus cosine. So what I'm going to do here is I'm going to get this. I'm going to put it underneath. Okay, so cosine theta plus cosine theta over cosine theta. What is 1 over cosine? Secant theta plus cosine over cosine, 1. That is simplified. Right? We simplified that out, and we're good there. Questions on that? So here I see this. I'm going to multiply this by secant theta plus 1. Okay? So my right-hand side, I have tangent squared theta times secant theta plus 1 over secant squared theta minus 1. Right? Now, secant squared theta minus 1, yeah, it's one of those Pythagorean identities that I'm going to use. I'm going to subtract 1 from both sides to get secant squared theta minus 1 equals tangent squared theta, right? Okay? So, tangent squared theta times secant theta plus 1 over tangent squared theta. Cancel, cancel. And we're just left with secant theta plus 1. Now, here, we have the same thing here. So we're good. The most efficient way. The straight line to the 1000 building. Right? Since this is the last one, I'm going to show you guys the long way. Okay? Going to the 5000 building, going to the bathroom, talking to your friends. getting a snack. Well, the thinking behind it is what is the main point. Okay, because I'm still going to use the same things on our guideline. Okay, so like what Alex said, the right hand side, I'm going to try and make the right hand side look like the left hand side. Okay, and you guys can just drop your pencils and look up and just follow. Okay, so I'm going to make the right hand side look like the left hand side. So I want to turn everything into sine and cosine. Okay, tangent squared is sine squared theta over cosine squared theta over secant is 1 over cosine minus 1. I see again a fraction, so I'm going to get the common denominator of cosine theta, right? So this one will be 1 minus cosine. Correct? Over sine squared over cosine squared. Now I have a fraction divided by a fraction. So using my basic math skills, I know that I can just take the reciprocal of this, right? Make it look like that. Okay. And then I can cancel out that guy. I can cancel out one of the cosines. So now I have sine theta over cosine theta times 1 minus cosine theta. Okay. Now I have no idea where to go. So I'm going to look back up here. Okay. 1 plus cosine on the top. I need a 1 plus cosine on the top, which will help me because if I need to make a 1 plus cosine on the top, I need to multiply this by 1 plus cosine. Right? Yeah. But that in turn gave me a difference of squares right here. So that's cool. I don't know if any of this is cool, but it's cool to me. 1 minus cosine squared theta then, correct? And this one would be sine theta times 1 plus cosine theta. So I got my 1 plus cosine theta. I'm not going to touch it. Okay? I got it. We're closer. Now I just need a cosine theta on the bottom. Okay, but what is 1 minus cosine squared? Yes, it is sine squared. Yeah. So this, I can turn this into sine squared theta. So this sine and one of the sines cancel out. Right? Oh no, this is sine squared. Okay? So actually this whole sine and this whole sine, they cancel out. They'll call back. Okay? You guys see that? So then I have 1 plus cosine theta over cosine theta. Yeah? Long way. Short way. I showed you guys the short way. Right? More efficient way. Go talk to your friends before 7th period starts. Way. That make sense? Yeah? Both ways are fine. Okay? So that is our lesson for today, class. and your work is on your Google Classroom.